Hello, this is Lab 5 of Opti 471b called Spherical Aberration. In this video, I'll have an overview of the theory of what spherical aberration is, the test setup that we use to measure it, and the results obtained by the end. So spherical aberration is one of the most important aberrations to correct for because it exists for all field points. It manifests as a difference in focus position depending upon the pupil location of the ray's origin. For this lab, there are three important parameters to point out. First is the marginal focus, the point at which the rays from the edge of the pupil cross the axis. Next is the paraxial focus, the focus position obtained by making a paraxial approximation. And finally is the longitudinal aberration, the distance between those two focus positions. In this lab, we measured the transverse ray fan at the marginal focus. This ray fan is a combination of two different aberrations. First, the cubic spherical aberration, and then next, the linear defocus term. To measure the ray fan, we broke the pupil into 9 distinct locations using a Hartmann mask. We lined a microscope by overlapping the original beam location, the expanded beam after the microscope, and the crosshairs of the microscope. This is an essential step because the microscope was used to find the location of the ray in all ray fan plots. Our final setup had only one bend that was used to scan across the Hartmann mask. The microscope was aligned to the marginal focus by passing a ray through the outermost edge of the pupil. Recall that the rays from the edge of the pupil cross the axis at the marginal focus. To ensure alignment, this was done for both extremes of the Hartmann mask. If well aligned, the difference in microscope positions would be minimal. The first attempt yielded a difference in microscope position of 1.8 millimeters, indicating that something was out of alignment or we weren't at the marginal focus. After this, the Hartmann mask was readjusted, and the difference in microscope positions was only 10 microns. Next, a transverse ray fan was obtained by scanning the beam across the Hartmann mask and moving the microscope in a transverse direction to determine the location of the beam. This was done for both the maximum and the minimum spherical aberration configuration factor. The maximum configuration showed a 200 micron spherical aberration, and the minimum configuration showed around 50 microns. Next, the longitudinal ray fan was found by scanning the microscope in the opposite direction, but this resulted in faulty data. The curve was expected to be smooth and symmetric on either end. After some investigation, it was determined that the Z translation stage for the microscope was slightly askew due to slop in the screws. The translation stage was reconstructed with this in mind. This time, a smooth longitudinal ray fan diagram was found, displaying 5 millimeters of longitudinal aberration. And that concludes the lab. Thank you for watching. I'll see you next week.